All right. This time we're going to talk about the surface area of a parametric curves. So they're going to give us two parametric equations, and we'll have to find the surface area that will be generated by that curve. Now, we go to example 2. So we are given x equals 14 times x cubed times cosine of theta cubed, and then y equals 14 times a sine cubed theta. And theta is between 0 and pi. And then the rotation is about the x-axis. So basically this graph looks like this. You have the xy plane, and that's the shape of the graph. So this graph is rotated about the x-axis, so it will generate a surface, and that surface is what we're looking for. What is the area of that given surface? So anytime you're dealing with a given two parametric equations, and they ask you to find the surface area, we will always use this formula, which is the integral from alpha to beta of 2 pi y. The reason is 2 pi y is because the rotation is about the x-axis. Now if the rotation was about the y-axis, then you'll change y to x. Okay, so, and then times the surface element. Now the surface element is that you take the derivative of x, you square it, and then you take the derivative of y, you square it, and then you take dt, where t is the parameter. So basically t is between alpha and beta. That's why you have those limits of integration. So this is the surface area of a given parametric curve. So in our case, instead of using t as a parameter, we're using theta. So our surface area is going to be the integral from alpha is the lower limit, so alpha is 0, and beta is the upper limit, which is pi, and then times 2 pi. Now y is given as 14 times sine cubed. So we're going to change y to theta. So basically we replace y with 14 times sine cubed theta, and then we can multiply this by the surface element that we need to find. And because the parameter is theta, so we're going to change t to theta. So you get this. So our goal is to find square root of x prime squared plus y prime squared. So we're going to start with x. Since we know that x is 14 times cosine cubed theta, so we are asked to find x prime. Now x prime is going to be 14 times. Then we're going to take the derivative of cosine cubed theta. That brings us to the power rule followed by the chain rule. So the power rule says that you have to drop 3, and then take away 1 from 3, you get square, and then apply the chain rule, which means you take the derivative of cosine, which is negative sine. Then it says square that, so you're going to square this, which we take 14 squared, and then times 3 squared. And then we're going to square cosine squared to get cosine to the 4th. And then we're going to square negative sine to get positive sine squared. So that gives us x prime squared. So now we can go to the y prime squared. We're going to start with y, which is given as 14 times sine cubed theta. Then we take its derivative, so that gives us 14 times 3, and then again power rule followed by the chain rule. And then we take the derivative of sine, which gives us cosine. And then we again follow the fact that we need to square that. So when you square it, you get 14 squared times 3 squared. And then when you square sine squared, we get sine to the fourth. And then when you square cosine, we get cosine squared theta. Alright, so we got x prime squared and then y prime squared. And now we needed to add them up. So x prime squared plus y prime squared is going to be, well, I have x prime here, and then y, and then you just copy those. And then plus, that's x prime. Here's y prime. I mean y prime squared. Okay, so now when I look at those two terms, I can see like terms. I can see that I have the constants are exactly the same. So I can factor out the constant 14 squared and then times 3 squared. Then when I look at cosine to the fourth, here I have cosine squared. So I can factor out 1 cosine squared. And then for sine, I have sine squared, and then sine to the fourth, so I can factor out 1 sine squared. Then, after that, I will have, by taking out cosine squared, I'm going to have 1 cosine squared left. And then plus, this plus sign. And then here, since I took sine squared out, then I'll have another sine squared left. So now we go back to trigonometry. We know that cosine squared plus sine squared is always 1. So we ended up with 1 times this quantity. So that gives us 14 squared times 3 squared. And then times cosine squared theta. And then times sine squared theta. So that gives us x prime squared plus y prime squared. So what remains is that we need to take the square root of x prime squared plus y prime squared. So we're going to do that. So since we don't need this now, so we take the square root, so x prime squared plus y prime squared. Take the square root, give us 14 squared times the 3 squared times cosine squared theta and times sine squared theta. And then you take the square root. So that gives you 14 times 3 times cosine theta and then times sine theta. Okay? So you remove all the squares by taking the square root. So now we have pretty much what we need. We can go back to the essay integral. So we have, this is what we have. So this integral is then integral from 0 to pi of 2 pi times 14 times sine cubed theta. And now this square root of x prime squared plus y prime squared is now 14 times 3 and then times cosine theta and then times sine theta and then d theta. There we go. So we have this integral to evaluate. So what I'm going to do is, the first thing to do is to bring all the constants outside of the integral. So I have a 2 pi times 14 and then times 14 again, and then times 3. So all those constants outside of the integral sign. And then I can integrate whatever is remaining. Now notice that here I have sine and sine cubed, so I can combine them as sine to the 4. And then cosine theta and d theta. So, okay. Now let's go back up here. So my integral is, if you multiply 2 pi, so you take 2 times 14 times 14 times 3, you're going to get 1176 pi. Okay. So that's when I'm going to continue. So this whole constant is that. Then I want to rewrite. So what I'm going to do is change this. I'm going to use U substitution. So instead of cosine theta d theta, I want to write it as the derivative of sine. Because we know the derivative of sine is cosine. Cosine. So instead of this, I can change this to d of sine theta. So the d means derivative. So the derivative of sine theta is cosine theta d theta. Alright, so that means that if you think of this as u, so this means u to the 4th. So you can just integrate using the regular power rule. So you get sine to the 5th theta over 5. So now, so what I'm going to do with the essay is that I'm going to change limits. So I'm going to first evaluate. So I'm going to change this. I'm going to go from this. Let me explain this quickly. So what I'm going to do is I'm going to find the surface area generated by this curve, half of it. So when I get the surface area, because the surface area generated by this piece and this piece are basically the same. So if I can find the surface area generated by this one piece from 0 to pi over 2, then I can just multiply by 2, I get the whole surface area. So that means that in terms of integral, it means that I'm going to integrate from 0 to pi over 2, which will give me this piece. Okay? So then for me to get the whole piece, because this piece, the surface area generated by this piece is the same as the surface area generated by this piece of the curve. So for me, if I can find one of them, then I can multiply this by 2 to get the whole thing. So this basically gave me the surface area generated by one piece. Then I can multiply this by 2 to get the surface area generated by the entire curve, this whole thing. So after I did this, my essay is then, you get 2352 pi times. Then I will evaluate sine to the 5th. Of course I can bring that 5 here, which is a constant. So then I can just evaluate as sine theta minus sine to the 5th of 0. And this gave me the answer. So we get SA equals to 2352 pi over 5 times. Now, sine of pi over 2 is 1, so you get 1 to the 5th, minus sine of 0 is 0. So this gives you 1, and this gives you 0. So 1 minus 0 is 1, so you ended up with the surface area is 2352 pi over 5. So that is the surface area generated by this parametric curve.